You're driving across the sea, not beside it, across it. The road runs straight out over open water, Tokyo Bay stretching flat and gray on both sides. No land ahead, just a thin ribbon of highway laid across the ocean. For a few minutes it feels almost ordinary, the way any long bridge feels. Then the road tilts down. Ahead, the lanes dip toward the water and simply vanish into it. There's no island, no far shore waiting. The highway runs directly into the sea and disappears. You follow it down, and the daylight goes with you. The surface of the bay slides past your windows until it's above you. Now you're driving beneath the ocean itself, with millions of tons of seawater held back by nothing more than concrete and engineering. You stay down there far longer than feels comfortable, kilometer after kilometer. No exits, no daylight. The sea remains above you the entire time, and after a while, you can't help wondering just how much water is overhead. And then the road climbs again, and you surface into the sun on an island that shouldn't be there. It seems connected to nothing. It sits alone in the middle of the bay, open water in every direction, but it isn't bare rock or a work platform. There are restaurants, shops, an observation deck, people leaning on the rail, looking out at the sea, a place to stop for lunch, in the middle of the ocean, halfway through a highway, which leaves one obvious question. Why would anyone build something this strange? If you needed to cross the bay, why not just build a bridge the whole way across, or dig a single straight tunnel underneath? There's a reason it was built exactly like this, one that only makes sense once you see the problem the engineers were actually facing, because before they could build it, they first had to solve a problem that defeated every obvious solution. The two cities sit almost within sight of each other, Kawasaki on one shore, Kisarazu on the other, separated by about 14 kilometers of open water. On a map, it looks like nothing. A short hop straight across the bay, but there was no way across. To get from one side to the other, drivers had to go the long way around the entire bay, close to 100 kilometers of road, through some of the busiest traffic in Japan. A 14-kilometer gap turned into a journey of hours. Every extra kilometer meant more fuel burned, more hours lost, and freight trucks crawling around a bay they should have crossed in minutes. The obvious answer is a bridge. Draw a line across the water and be done. Except, you can't. Tokyo Bay is one of the busiest shipping lanes in Japan. Huge cargo ships pass through the bay day and night. A normal bridge would sit directly in their path. So you go under, build a tunnel instead, but that's where it gets worse. The bay is up to 70 meters deep. Beneath it is soft, waterlogged mud. And this is Japan, one of the most earthquake-prone countries in the world. Building a tunnel that deep, beneath the sea, through unstable ground, wasn't just difficult. It pushed the limits of what engineers believed was possible. So there it was. You couldn't go around it. You couldn't bridge it. You couldn't tunnel it either. Every obvious solution had failed. And yet, the crossing got built anyway, not by picking one of those answers, but by refusing to choose between them. So the engineers stopped asking the wrong question. It was never bridge or tunnel. Neither one could solve the problem alone. So instead of choosing between them, the engineers combined both. Look at where the trouble actually was. The busiest shipping lanes were all on the Kawasaki side, where huge cargo ships passed every day. The Kisarazu side was shallower and far less busy, with no major shipping traffic to worry about. The bay wasn't one problem. It was two, sitting side by side. So they treated it as two. On the shallow Kisarazu side, clear of ships, they built a bridge, about 4 kilometers of it. Far simpler and far less expensive to build, out in the open air. On the Kawasaki side, beneath the shipping lanes, they sent the road underground, a tunnel nearly 10 kilometers long, running beneath the seabed while cargo ships continued passing overhead, never knowing a highway ran beneath them. And here's the quiet genius of it. Where the tunnel ends and the bridge begins, out in the middle of open water, they raised an artificial island, a place where the highway could rise out of the tunnel and seamlessly continue across the bridge. Ships kept moving. The tunnel only went where it absolutely had to. The bridge handled the easier stretch. Every part of the design solved a problem the others couldn't. It wasn't luck. It was the bay, read correctly. But solving the problem on paper was the easy part. Building nearly 10 kilometers of tunnel beneath a living sea was something else entirely, and it would push these engineers to the very edge of what was possible. Now the hard part. How do you actually dig a tunnel under the sea? You can't just scoop out a hole. The water would pour straight in. So instead, they used a giant machine called a tunnel boring machine, or TBM, protected by a massive steel shield. Imagine a giant steel cylinder, wide enough to swallow a 4-story building, with a massive spinning cutter at its front. It chews through the mud, and its hard shell holds back the sea while, right behind it, workers build the tunnel wall out of thick concrete rings. The machine crawls forward, and a finished tunnel is left behind it. It was like building a tunnel from the inside out, one concrete ring at a time. And these machines were monsters. Each one stretched 14 meters across, stood as tall as a 4-story building, and weighed more than 3,000 tons. At the time, they were among the largest tunnel boring machines ever built. 8 of them were made for this one job. But down there, everything fought back. 60 meters below the surface, the pressure was immense. One failed seal, and seawater could come rushing in. The seabed wasn't rock. It was soft, wet mud that wanted to cave in. And this was Japan, where earthquakes can strike without warning. The tunnel had to survive those too. Then came the moment that could ruin everything. The machines didn't dig from just one side. They started from opposite ends, crawling blindly through the mud beneath the sea, with only one chance to meet at exactly the right point. Miss? And there was no second try. They didn't miss. The 2 tunnel sections met beneath the bay, lined up almost to the millimeter. And where it climbed back toward the light, the engineers had built something no one expected. Remember that island from the very start, the one that shouldn't exist? Time to meet it properly. Its name is Umihotaru. In Japanese, that means sea firefly, a tiny creature that glows in the dark water, and the name fits. At night, surrounded by darkness, the island lights up and seems to float like a glowing firefly on the surface of the bay. Step inside, and it feels impossible. 5 floors rising straight out of the ocean. Restaurants, cafes, shops, open-air decks with panoramic views in every direction. The Tokyo skyline on one side, and on a clear day, Mount Fuji on the other. A place to stop for lunch in the middle of a bay, far from any shore. But here's the twist. Umihotaru wasn't built for the view. It's there because the highway has to change from a tunnel into a bridge. This is the exact point where the tunnel ends and the bridge begins, and the highway needs somewhere to climb up out of the sea and switch from one to the other. The island is that switch. The restaurants and cafes came later. Beneath them is one of the most important pieces of the entire crossing, and it isn't the only island. Closer to Kawasaki stands a second one, 2 tall towers shaped like sails. No shops, no visitors allowed. Its only job is to keep the tunnel breathing, pulling fresh air down to the traffic below and helping remove exhaust from the cars inside. Even the beautiful things out here are engineering in disguise. The crossing was finally complete, but building it had taken more than 30 years and cost well over 1 trillion yen. And one question still remained: was it actually worth it? So after 30 years and more than 1 trillion yen, was it worth it? Start with the simplest test. The drive that once took around 90 minutes now takes about 15. The long journey around the bay is gone. Hours became a coffee break. For people living on one side of the bay and working on the other, the Aqua-Line didn't just save time. It changed where they could live, where businesses could grow, and how goods moved across the region. And it reached further than the road itself. The Boso Peninsula, including Kisarazu and the surrounding towns, had long felt cut off from the Tokyo metropolitan area. Almost overnight, it found itself just 15 minutes from one of Japan's largest industrial regions. New shopping centers, outlet malls, Housing developments and tourist attractions began to appear. Even Umihotaru itself became a destination, drawing visitors who simply wanted to experience a highway stop in the middle of the sea. A crossing built to move cars ended up moving a whole local economy. Then, the harder test: survival. Tokyo Bay is a harsh place to build anything. Earthquakes, typhoons, and saltwater attack the structure year after year. The crossing was built to bend in a quake, stand through a storm, and resist the slow rot of the sea. And it has. More than 25 years later, tens of thousands of vehicles still cross it every day, and Umihotaru still lights up the middle of the bay every night. So yes, it worked, or at least almost everything, because there was one promise the project never fully delivered. Here's the promise it broke. For all its brilliance, when the Aqua-Line opened, almost nobody drove through it. The reason was the price. Crossing the bay cost around 4,000 yen, roughly $40 one way. It was the most expensive toll road in Japan, and one of the most expensive in the world, so drivers did the math and stayed away. In its early years, traffic wasn't even half of what the planners had counted on. The economic transformation planners had hoped for arrived much more slowly than expected. A trillion-yen crossing sat half-empty over the sea. For years, critics questioned whether the project would ever justify its enormous cost. Then, in 2009, the government tried something drastic. They cut the toll for electronic pass users all the way down to 800 yen, a fraction of the original price, as a deliberate push to wake the region up. And it worked. Traffic finally poured in. The outlet malls, the tourism, the growth from earlier. Most of it came after that day, not before. The Aqua-Line didn't become a success overnight. Lower tolls played a major role in helping it reach its potential. Even today, not every original goal has been fully achieved. One hope was that the Aqua-Line would pull traffic out of crowded central Tokyo, but the toll stayed high enough, long enough, that most of that shift never happened. Add the endless cost. An undersea tunnel is something you must fight the sea to protect. Forever, corrosion gnawing at it every day, and the honest verdict is mixed. The Aqua-Line stands as both an extraordinary engineering achievement and a reminder that solving impossible problems often comes with extraordinary costs. But step back, all the way back, and the Aqua-Line stops being about Japan at all. Because the real lesson isn't about a tunnel, or a bridge, or an island. It's about how the engineers thought. Faced with an impossible problem, they didn't force a single solution onto it. They stopped asking, should we build a bridge? Or should we build a tunnel? And asked a better question, what combination actually solves the problem? That's the quiet genius of great engineering. It's not about building bigger or stronger. It's about understanding the problem so deeply that the solution seems obvious in hindsight. Japan didn't defeat Tokyo Bay. It worked with it and left behind a road that still feels like magic.